to my training session. In this training, I'll be showing you how to produce a final survey plan using Qgis software. Already, the data we'll be working with has been downloaded from the data logger and saved in my project folder. So that is what I'll be working with today. The data first. The first thing you have to do is to import the data you want to work with. That is the CSV, the final collected coordinates of the layout. It will prompt for the coordinates reference system. So you select the system you want to work with. So the data has been imported into the Qgis environment, as you can see. You can also check, this is the attribute table. This is how it usually comes. So after importing the data, the next thing you do is to save it as a shapefile, because you won't be able to make any edits on this CSV layer. So you save it as a shapefile to enable you make edits to the layer. It's already in me now. Then you browse to your project folder. And then you can remove the CSV file for an organized work. Okay, so the next thing now to do is to carry out a quality check on the collected data by comparing the raw field coordinates, the data that was taken to site, with the collected coordinates. So that is what you should do first. I don't have the field data here, so I'm not going to do that now. But in a real practice, you have to bring in the field data first and then check the difference between the stakeout points, that is the field data, and the collected data. It should not be more than 10 cm. The difference between the field, the stakeout points, and the collected points should not be more than 10 cm. And you also have to check the beacon numbering as well to ensure that the numbering was done correctly. So we will go straight into the map making. At this stage, you will need the field map with you, because we have to digitize these points using a polygon tool. We'll digitize them using a polygon tool. So you need the field map handy to know which points should be joined to which point. So right here I have my field map. So I'll follow the field map. Will serve as a guide in the digitizing of these points using a polygon tool. So first of all, I'll create a shapefile for polygon. I'll call it the plot. So we will now start digitizing. Remember to save your work. To also help you with the digitizing, you can label the point so that you will know which beacon number leads to which beacon on your map, the field map you have. So you will continue digitizing with the polygon tool using your field guide, block by block, until you're done. So as you can see, we have the points with beacon numbers and our polygons. So now we create a shapefile for line, which will be used to generate our distances and bearings for each polygon. You can call this distance. And then we'll start digitizing with the line tool. You will connect to each 2 points with a line, just as you can see me doing. Like I said in the first video, in the previous video on how to produce field map, you digitize block by block. You digitize your lines block by block, just as you add your points too. The same way you digitize the points in a clockwise manner. Okay, after this block, I'll go to the next block. Always remember to save your work. Okay, I can also change the color to red, the line color, from properties. Okay, then you save. So the next thing is to generate the distances. So I'll be doing that on the attribute by creating a field for distance. And then I'll run the code for distance. You select the column where you want to update, and then you type in dollar sign and length. You update. So these are the distances. Then you can create another field because you need to add meter to these distances. So I'll be creating another field for meter. There are various ways you can do this, but we'll stick to this method for now. I'll select the field I want to update and then type in the code for adding meter. Then update. Now you have the meters added to the distances, the distance values. Then save. I can label the distances now. Rendering. So you can see the labeling of the distances. You can see them. Then I can also change the style for these points from the properties too. Usually we use this symbol to represent our points. Then the label, change it to Times New Roman. Times New Roman, maybe 8.0. Okay, so this is what we've got so far. You save. Then the next thing to do is to create a layer for your bearings and then generate the bearings too. So that's the next thing we're going to do. So now instead of digitizing all these lines over again for bearings, because the shapefile for line for your bearing is the line 2, is a line type, is a line. You use a line for your bearing. So instead of digitizing these lines over again, I can just this distance as, I can save it as a bearing or duplicate this distance layer. Bearing, save, then you add saved file to map. Okay, now you have the bearing added to your map. So on this bearing layer, I would generate the bearings of these lines and then label them. So let's go straight in. Also from the attribute table, create a field for bearing. Okay, for the bearing, to generate the bearing, there is a code. So you copy this code and paste it on the calculator. Select the field you want to update, and then that's all. The bearing field gets updated. I can now label this field, this bearing with the field. Bearing, and also the style. You change, and then the placement should be left of the line. The bearing should be left of the line. That's the positioning, while the distances should be on the right of the line. Test times okay, at this point you have your distances, you have your beacon numbers, and you have the bearings of the line. So we also need the plot number and the area. You need to display the plot numbers of these polygons and the area on the map. To display the plot numbers, you need, okay, let's go down to the area first. Already I have a shapefile for plots. So on the attribute table, I'll be creating a field for area. And then I'll generate the area of the polygons. Select the field you want to update and click on update all. So from at this point, you create another field because you need to add meters to this area. There are other fields too. To add meter square to the area, to add the units to these figures, I'll create another field as a test, and then I'll copy the meter squares from here. The same way we did for adding the distances, the meters to the distances, we will do the same thing for area. Select the field you want to update, and that is it. You have your area. So you now have to label the area using the meter square field. Force it into polygon test. Slowly. Oh, okay. So, like I told you, plot number, for the plot numbers, you would need a polygon feature to have your plot numbers. So I would have to save these plots in order to duplicate the polygons instead of digitizing over again, just like we did for the bearing and distances. So I'll save those plots as plot number. Okay, this is in case you don't have the plot, but usually the town planners during the design will assign plot numbers to these plots. So what you should do normally is to import the town planners plot number shapefile, which you would work with. You are not to adjust or alter the plot numbers. So that is what I'll be doing now. So I've added the plot number as designed by the town planners. If you open this attribute table, you would see that there is a field for plot number which has the plot numbers on it. So these are the numbers we'll be using for each of the polygons. You are not to alter these numbers. Now I can make this plot number transparent so that it doesn't cover from here. You make it transparent. Okay, and then you label it. Make this one 7. Okay. You can see from this drawing that the plot number and there's an overlap on the plot number with the area, as you can see. And also looking at the design, looking at our map, we can see some features colliding, just like this one. So at this stage now, editing your work to make sure no write-up collides on another. And then also we need to add all other features we need to make this map, like the road. We check if there is any stream on this layout or around it. So from the town planners design, I'll import the road shapefile. Okay, now I have complete data to work with. I have the roads, I have the plots, I have the plot numbers, the area, the distances and bearings, and the beacons with the beacon numbers. So I have complete information to work with, complete data to work with. Then for this road, I'll change the style for the road. You use dash line and it should be black. Apply and OK. Even though there are no road names here, so find the road names later on when we are making the final map, the map on the composer. We would have to label these roads with their road names. Okay, So looking at this map, you will see that there are some distances like this one. The collision is colliding on the beacon numbers and on the line. So we'll have to tabulate most of these short distances. Let's say distances that are less than 7 meters. They are mostly along the truncations. So we'll tabulate these distances and then we'll tabulate it on the map and then delete them from the map, from this interface, so that our map will be neat. So to do that, I'll from the distance layer, I'll select all the distances that are not more than less than 11 meters. Like I told you, mostly on the truncations. So after selecting all the distances, you save it as tabulation. Save only selected features and then OK. So you have your tabulation layer. So, and then we'll go to the attribute table. This is our tabulation. This is the layer for tabulation. So for the tabulation, you need the distance field, the bearing field. You need a field for from, to, at, equal to, and a lot of them. So that is what I'll be doing now. I'll create a field for bearing first. Just like we did before, you copy the code, paste, and then update. So you need another field for from. Okay, these are all the fields you be needing on your tabulation, the tabulation layer. From point A to point B equal to bearing at distance. So that is how it will be arranged on the composer. So I have to fill up all these fields in this manner. Let's start with, we have the bearing with from. can see the code I'm using to fill it up. Update to select the field, update at to. Okay, back to again. Maybe this one. So we're left with point A and then point B. So for the point A and point B, you're going to be selecting the line. You're going to select the feature, zoom to the feature. This is the line. And then you will check using the, so with the knowledge of the quadrants you have, you will check if the line is going in this direction or in the opposite direction. You use bearings. As you can see, this is 290 degrees 51 minutes. So clearly it is going towards this direction. It is going from this point to this point. So I'll be imputing this beacon number in point A and this beacon number in point B. That's F428G. G in point A. And F430G in point B. In point B. I'll do it for the next one. We have 53 degrees 25 minutes. From our quadrants, you can see that it's going from this point to this point. From F435G to F437G. So that is how you will keep doing that till you update all these fields with the beacon numbers, and then you have a complete tabulation field layer. So we'll go to the next one. So having filled up the fields on your tabulation, you will now disable these bearings and distances on the tabulations from being labeled. Instead of deleting them one after another, you can do that from the properties. Go to rendering. That is, you will do that on the distance layer, not on your tabulation now. You're doing that on your distance layer. Go to properties. From rendering, you click on show label. Sorry, I have this here. Then you select the field. Which field do you want to work on? Select distance. Operators. This 11. Okay. So you can see all the distances that are not more than 11 meters have been disabled from being labeled. So you will do the same thing for the bearing. Always select distance because you're working with the distances. You can see makes your work clean. So at this stage now, you can start making. So to make the map, we'll click on new print composer. I will save this as map 1. Then takes me to the composer interface. You select the paper type you want to work with, the paper size. Let's say A2 paper. And then the orientation. Looking at the map, looking at the shape of our map, you can see that we can go with either portrait or landscape. So let's say landscape. And then, so these are the two basic settings you have to do on the composition before you start making your map. So I'll then, that's the border. You click on it and you drag it. Okay, so this is my border. Then you add the map. Click on this tool. Sorry, you click on this tool and add the map. Because it's heavy, sometimes it takes a while to come up. Okay. Okay, so I've changed to, you check the scale of the map. So now I can now add the title of the and every other feature I want to add on the composer. Then you can add the tabulation as an attribute table. From the attributes, you arrange it the way it should be. You move from up, then from point from to point to go to response. Let's go. Okay. Remove the header. You can refresh. So using the test tool, you type in who surveyed it, who did the survey, the plot matching, the drawing, who checked it, who passed it, and all that. You just use the test tool and add up this, then add the UTM, the coordinate. Then you also have the computation number and the plan number here. Using test, you add it. This is KDLP, just as you have on the title 1240. These are all tests. You add them using the test tool. Then for this one, you have to edit it using the coordinates of the real coordinates of a beacon you want to work with. Let's say F431G. So I will check for the coordinates of F431. You select it and then show selected features. This is the instance. You copy, you change it here, paste, and then the last names, change it here, paste. The beacon number, you have 431, F431G. F431G. G. So that is it. So the next thing you add now is the north arrow. You add the north arrow. Okay, then you have the road names. Using text, you add the road names. Let's say road A. It should be bold, then you rotate it. To align with the road. Okay, you do same for this road. Should be okay. Then I'll add the scale. You add the scale of the map. Numeric. Okay, let's say double box. Because you're working in 1,000, you're selecting 10 and not 50. But usually you have to write the skill with a test in this way. One cm to 10 meters. Okay. So you can click on this one to one to see exactly how your map will be printed. So this is your map. So having done all the necessary, added all the necessary features and all that, you take a good look at your map before you export it for printing. And then you export the map as an image. You save it on your work folder under the print folder. You're saving it with the paper size, the name of the TPO, underscore the paper size. Save. Okay, our map has been exported. Okay, I didn't add the grid. I think we omitted the grid. You have to add the grid to the map by clicking on grid, draw grid, and then you play around with this figure to see if the calibration will be okay for you. Let's see 100. Okay. Vertical, vertical, then the font, then position 0, and then you select on, click on frame to add a frame to the map. Before you export, you save and export. So I have to overwrite previous exported map. So let's go to the work folder to see our exported map. So this is it. This is a map we just produced now using goodbye.